Okay, today's topic is right triangle, trigonometry. Some of you may be familiar with some right triangle trigonometry. If I have a right triangle, let's say we have a triangle, this is a famous right triangle, probably the most famous right triangle, sides of 3, 4, and 5. And we know it's a right triangle because 3 squared plus 4 squared is equal to 5 squared. Follows the Pythagorean theorem. Well, this triangle has two angles in it, two acute angles. There's, of course, the right angle, but the two acute angles. And traditionally in trigonometry, we'll probably label this like A, B, C. And we could put some different angles in here, and a lot of times what we'll do is we'll put Greek letters in there. It's tradition in trigonometry is to use Greek letters. So we'll put a theta here, and here's another Greek letter. We'll call that one alpha. So we label triangles with points, capital letters, and we label angles with Greek letters at times. Now, sometimes we can label the angles with the capital letters as well, but you know, most of the time in trigonometry, these Greek letters are used. So you've probably heard the expression so ka toa, and that's a way of remembering right triangle trigonometry. And what this means is that the sine of an angle is equal to the opposite side from that angle divided by the hypotenuse. The cosine of an angle is equal to the adjacent side next to that angle divided by a hypotenuse. And I'll explain what these mean here in a second. And the tangent of theta is equal to the opposite side in the right triangle divided by the adjacent side. Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. Let's go back to our right triangle. And I'll draw it without the ABC. Probably look better that way. 3, 4, 5. And here's theta. And there is alpha. Okay, in this right triangle, if I concentrate on angle theta, the hypotenuse, well, first of all, the hypotenuse is the hypotenuse. It's the only side, and it's always the longest side in a right triangle. It's the only side that is across from the right angle. If I look at angle theta, this side is considered to be adjacent to angle theta because it touches angle theta. That side, the 3, is considered to be opposite angle theta because it does not touch angle theta. If I look at angle alpha, the 3 is adjacent and the 4 is opposite because the 3 touches alpha and the 4 does not touch alpha. It is opposite. So I can write this. The sine of angle theta is equal to the opposite side 3 divided by the hypotenuse 5. The tangent of angle theta, well, pardon me, we usually go cosine first. Cosine of angle theta is adjacent 4 to theta because it touches theta divided by hypotenuse 5. And the tangent of theta is equal to opposite of theta divided by adjacent of theta, 3 divided by 4. Looking at alpha, the sine of alpha is the opposite side from alpha, which is 4 divided by hypotenuse 5. The cosine of angle alpha is adjacent 3 divided by hypotenuse 5. And the tangent of alpha is opposite 4 divided by adjacent 3. Now you'll notice that the same numbers come up in the sine, cosine, and tangent ratios. And for example, the sine of theta is equal to the cosine of alpha. The cosine of theta is equal to the sine of alpha. and the tangent and the cotangent of these two are reciprocals to one another. That's the thing about trigonometry is that there's a lot of repetition in trigonometry, and we'll see that especially when we get to angles that aren't between 0 and 90 degrees. But today's topic is just on right triangle trigonometry, and we're just going to concentrate on these ratios within a right triangle. Okay, I'm going to flip my paper over and recreate. Let me see if I can get it in the right place. Trying to get little markings on the table here so I know where I am. I'm going to recreate my right triangle again with the 3, 4, and 5 and my theta and alpha. Okay, let's see if you remember. Sine theta. How do you get it? Opposite over hypotenuse. 3/5. Cosine theta. Adjacent over hypotenuse. 4/5. Tan theta is equal to opposite over adjacent 3/4. Now you may, and keep in mind, you may want to write this down as you work. So katoa. A lot of people like to remember that. But we're going to add more here because you probably already knew this stuff. And if you look in the book, well, you don't have the book, that's right, because we didn't take any home with us. I will put this here so you can see it. They talk about 6 trigonometric functions, and there are 6. They're the ones that you know, the sine, cosine, and tangent, and then there are these others, what are called cosecant, secant, and cotangent. Now, they give these definitions in the book, and I'll take a picture of this and I'll post it for you, so if you like definitions, and some people do like definitions, they can use definitions. But these functions over here, these 3 are known as the reciprocal functions because they are reciprocals of the 3 basic trigonometric functions. Now, another thing I mean about the basic trigonometric functions, if I take a look at the grapher, the grapher has on it the sine, cosine, and tangent. It doesn't have the other ones on there because they're reciprocal functions, and the grapher can easily take reciprocals, so we don't need a button for any of these things. But the sine, cosine, and tangent are very important functions in mathematics, especially in trigonometry, obviously. So they are on the grapher. And we're not going to really use the grapher for these purposes today, but we will in the very near future. Okay. So if you look at the 3 trigonometric functions, the other ones being the reciprocals, now look, the sine is a over c based on this triangle up here. Cosecant being c over a. It's nothing more than the reciprocal. Cosecant is the reciprocal of sine. If you know the sine, you just flip the fraction upside down and you got the cosecant. Okay, cosine and secant are reciprocals. Tangent and cotangent are reciprocals. Okay, I'm going to move the book and go back to our example. Now, for your homework tonight, there are going to be examples like this where you're going to be asked to find all 6 trigonometric functions. All right, so all you have to do is list the 3 from SOHCAHTOA, and then right next to them, write this. Cosecant of theta is nothing more than the reciprocal. Secant theta is reciprocal of cosine. Cotangent theta is the reciprocal of tangent. And that's it. In order to list the 6 trigonometric functions, list the 3 by SOHCAHTOA, and then write the reciprocals right next to them. It's very simple. Okay, let's take a look at what we're going to do for homework tonight. Or I should say, for our assignment. I always call it homework, but we're not giving homework. We're only giving assignments. Okay, we're going to do out of the book, and I've posted the problems. We'll do the odds and you do the evens, of course. Okay, problem number 1. They give us a triangle. Looks like this. triangle ABC. There's theta. They put it in there for us. They give us sides 9 and 12. They don't give us the third side. Well, you're to figure that out by Pythagorean theorem. So normally we call the side opposite vertex C by lowercase c. So we'll write this. 9 squared plus 12 squared is equal to c squared. Pardon me. 81 plus 144 is equal to c squared. Those two things add up to 225. The square root of 225 is 15, so c must be 15. Write it like this. C is equal to 15. Now you are supposed to list the 6 trigonometric functions. Here, let me put that there. Okay, so I'll put them, let's see, I'll do it right here. I was asked to write a little bit bigger. Okay, so sine of theta, opposite over hypotenuse, 9 over 15. Now we should be able to reduce that. Both of those are divisible by 3, so I'll write that as 3/5. So, you know, some of you may notice that this triangle, 9, 12, 15, is a similar triangle to the one we were dealing with up here. Cosine of theta is equal to 12 over 15, which reduces to 4 over 5. And tangent of theta is equal to 9 over 12, which reduces to 3 over 4. Well, see, these are the same as the ones that we just did. Cosecant theta is nothing more than reciprocal, 5/3. Secant theta, 5/4. Cotangent theta, 4/3. Okay. Need a piece of paper. Okay. Number 3. Okay, the triangle this time looks like this. Here's the theta. Triangle ABC. This is given as 21. That is 29. Okay, now we're looking to find this side. We'll call it A. Okay, again, A squared plus 21 squared is equal to 29 squared. 21 squared is 441. 29 squared is 841. Subtract the 441, I get 400. Square root of 400 is 20. So that is 20. Sine of angle theta, opposite 20 over hypotenuse 29. Cosine theta, adjacent 21 over hypotenuse 29. Tan theta is equal to opposite 20 over adjacent 21. Cosecant theta is the reciprocal of sine, nothing more than reciprocals here. Secant theta, reciprocal cosine, 29 over 21. Cotangent theta, reciprocal of tangent, 21 over 20. Okay. All right, numbers 5, 7, and 9 aren't tremendously different than this, so I won't spend any more time on them. You can do them, and, well, you don't have to do them, but you have to do 2, 4, 6, and 8, and then you're going to also do, on the next page, numbers 10, 12, 14, and 16. I'm going to move that back. All right, so let's take a look at that. These problems on the pages, on the next page, numbers 10, 12, 14, and 16, they deal with what, and we're going to deal a lot with these angles. These are the standard angles. The standard angles are all multiples of 30, 45, and 60 between 0 and 360. And they come from these very special right triangles. The 30, 60, 90 triangle and the 45, 45, 90 triangle. Here, I'll put those on this paper as part of the notes, and I'll post these notes for you. Okay, now you guys may have noticed up on the front board I had these triangles up there for a long time for the pre-calculus classes, and we're going to use them too. Oops. It's not the greatest triangle I've ever drawn. Okay, that's because my lead is falling out. Okay, so we got a 45, 45, 90 triangle. Now, all 45, 45, 90 triangles have these ratios. Sides of 1, 1, and square root of 2. Now, they may be bigger than that. They could be, you know, this thing could be twice that size. Jeez. And this would be 2, 2, and 2 times the square root of 2. But there'll still be a 45, 45, 90 triangle. The other one is the 30, 60, 90 triangle. In the 30, 60, 90 triangle, the smaller angle is 30, the larger is 60, and it has sides of 1, 2, square root of 3. The 1 is opposite the 30, the 2 is the hypotenuse, and the square root of 3 is the other. You'd be well advised to memorize these two triangles and know them. I know some of you took the SATs, but they will show up. You know, when we talked about the SAT prep, these triangles do show up, and they give them to you. But yeah, you should know what these things mean. All right. Well, anyhow, there's a lot of times we have the sine, cosine, tangent of the standard angles. Okay, so I'm going to ignore this one and just use these two to write some of these things down. So you could be asked something like this. What is the sine of 45 degrees? Well, if I look at the triangle here, sine of 45 degrees, opposite 1 divided by hypotenuse, square root of 2. Now, just about every math book I've ever seen will never allow you to write 1 divided by the square root of 2. We have to do what's called rationalize this, and that is to multiply it by the square root of 2 divided by the square root of 2. That's 1, of course. What that does is square root of 2 times square root of 2, that puts a 2 in the bottom, and we end up with this equivalent amount. 1 divided by the square root of 2 we won't write. We'll write the square root of 2 divided by 2. Now, hopefully you'll be able to see this. I know on one of my videos this was a little blurry. I don't know what happened with that one. But just to show you that 1 divided by the square root of 2 is 0.707. The square root of 2 divided by 2, oops, is also 0.707. They're equivalent numbers, but this is the way it's supposed to be written. Cosine of 45 is equal to 1 divided by the square root of 2, which is also the square root of 2 over 2. Tan of 45, opposite divided by adjacent, is 1 over 1 over 1. These numbers come up all the time. Now, the reciprocals of those, secant of 45 degrees is equal to the square root of 2 divided by 1. I should have put the cosecant next to the sine, because the cosecant is the reciprocal of the sine. Secant of 45 degrees is also square root of 2 over 1. And cotangent of 45 degrees is the reciprocal of 1, which is 1. Okay, let's look at this triangle. Sine of 30 degrees. That'd be 1 divided by 2. Opposite divided by hypotenuse. Cosine of 30 degrees is equal to square root of 3 divided by 2. Adjacent divided by hypotenuse. Tan of 30 degrees is equal to opposite 1 divided by the square root of 3. Now we're not going to leave that down there. We're going to multiply that by the square root of 3 over square root of 3, and this is going to be the square root of 3 divided by 3. So anytime you have a square root in the bottom of the fraction, multiply by 1 that square root divided by itself, and that will what's called rationalize that fraction. Rationalize the denominator. Okay, well, I did a number of the problems in numbers 10, 12, 14, and 16 for you. However, a couple of them are asking you for radian value. Now, you might have to convert those into degrees before you can deal with the radian value. So your assignment numbers 10 to 14 or 10 to 16 even, they deal with these triangles, and the other ones dealt with these triangles. You had to find the third side. Okay, so your assignment, section 5-2, numbers 2 through 14 even. And that's it. You guys can get in touch with me by putting questions on that page that I set up. I haven't gotten many. I have been putting the answers online, so I'm assuming that many of you are just looking at the answers and copying them down. If you have questions, you can ask. I will take pictures of these notes that I just made, and I'll post those, and I'll also put the answers for the homework up for you as well. All right, we'll see you tomorrow.